Hi friends, today we're going to talk about solving a system of linear inequalities. So we already know how to graph an inequality on the graph. Today we're going to learn how to graph two different inequalities on the same graph and figure out where the solutions lie. First part here, we're just going to check and see if a point matches or if a point is a solution to the system of inequalities. So this first one, we'll plug in -2 for x and 4 for y. We need to make sure that we plug those into both of these inequalities to see if we get a true or false statement back. So for our first inequality, -2 plus 4 times 4, is that greater than or equal to 10? Well, -2 plus 4 times 4 is 14, and 14 is greater than or equal to 10. Since that's true, we have to check the second inequality as well. 3 times -2 minus 2 times 4, is that less than 12? Well, that gives us -14, and -14 is less than 12. So our final answer then is yes. That point is a solution to that system of inequalities. All right, we're going to do the same thing here, but now our points are going to be 3 for the x value and 1 for the y value. So in our first inequality, 3 plus 4 times 1, is that greater than or equal to 10? Well, 3 plus 4 times 1 is 7, and 7 is not greater than or equal to 10. So I don't even need to check my second one. If it's no for either option, then it's no for the whole thing. So my answer is no. That ordered pair is not a solution to my system of inequalities. Let's try one more. So we have two new inequalities here, or a new system of inequalities. We'll plug in 3 for x and -1 for y. So for our first one, 3 minus 5 times -1, is that greater than 10? 3 minus 5 times -1 is 8, and 8 is not greater than 10. So since I got no, my whole answer is no. Try one more here. Plug in 6 for x and -3 for y. So in our first inequality, 6 minus 5 times -3, is that bigger than 10? 6 minus 5 times -3 is 21. And yes, 21 is greater than 10. So we have to check our second inequality to see if it works. 2 times 6 plus 3 times -3, is that greater than -2? This ends up giving you 6. And yes, 6 is greater than -2. So since it works for both inequalities, my final answer is yes. We're also going to graph a system of inequalities. So here's the steps. We have to graph the first inequality and shade it in the appropriate spot. Graph the second inequality, shade it in the appropriate spot. And then the solution is the region where the shading overlaps. We're not going to be doing step 4 here. We don't need to worry about that. So let's look. X minus y greater than 3, and y is less than -1/5 x plus 4. We have to get y by itself on this one. So if I started by subtracting x from both sides, I would get -y greater than -x plus 3. And then dividing everything by a -1, I would get y less than. Remember, we need to change the symbol if we're dividing by a negative. -x divided by -1 is positive x, and 3 divided by -1 is -3. So my first one that I'm going to graph, y less than x minus 3. So that has a slope of 1 and a y-intercept of -3. We can say the slope is 1/1. So I'll start down at -3. go up 1 over 1. I'm going to do that a few times here so I can be accurate with my line. Since it's just less than, I know it's going to be a dash line. We'll extend that in both directions. And since it's less than, we're going to be shading below. I'm going to do my second one in a different color. If you're going to be doing this on Notability, I would suggest using 2 different colors. So for this one, my slope is -1/5, and my y-intercept is 4. So I'm going to start up at 4, and then go down 1 and over 5. I'm going to do that one more time, down 1 and over 5. Again, it's just less than, so it's going to be a dash line. Do that in both directions. And this is y less than, so this is also going to be shaded below. So I'm going to shade everywhere below that line. And then I can see my overlapping area there is the solution. It's not a bad idea to kind of darken in the part where they're overlapping so we can tell exactly where the region is. So that I just colored in black there is where the 2 inequalities overlap each other, where the red and the blue overlap. So got another one, x plus y less than or equal to 2, and y greater than or equal to 2/3 minus 1. This one I need to get y by itself. So if I subtract x from both sides, I would get y less than or equal to -x plus 2. So this has a slope of -1 over 1 and a y-intercept of 2. So we'll start at 2 and then go down 1 and right 1. This is less than or equal to, so this is going to be a solid line. We'll do that in both directions. And it is less than or equal to, so we're going to be shading below this line. All right, and then our other one, greater than or equal to 2/3 x minus 1. So here my slope is 2/3, and my y-intercept is -1. So I'm going to start at -1, and then go up 2 and over 3. I'll do that one more time. It's greater than or equal to, so we're going to be doing a solid line here. And this one is greater than or equal to, so we're going to be shading above our blue line, all above. And you can see where it's going to overlap each other. So where red and blue overlap, I'm just going to darken that part a little bit more, just so we can see exactly where these are going to be, or where the region is, the overlapping region is. So anything in that black shaded region, any point in there would be true for both inequalities. I could choose any point in that whole part. If it's just blue, then it's only true for the second inequality. If it's just red, it's only true for the first inequality. And if it's empty, like this part right here, that means it's not true for either inequality. So get a couple more here. This first one, I'm going to get y by itself, so we'll start by subtracting 3x. You get -2y less than or equal to -3x plus 6, and then divide everything by -2. And I get y. I need to switch the symbol, so greater than or equal to 3/2 x minus 3. So our slope is 3/2, and our y-intercept is -3. So we'll start down at -3 and then go up 3 and right 2. I'm going to do that one more time. It's greater than or equal to, so this is going to be a solid line. That one wasn't exactly straight. There we go. And it's greater than or equal to, so we're going to be shading above this line. And then our second inequality, our slope is -1/4. Our y-intercept is 5. So I'm going to start at 5 and then go down 1 and right 4. I'll go down 1 and right 4 again. This is just greater than, so it's going to be a dashed line. And since it's greater than, we'll shade above that dashed line. And again, you can see the overlapping parts. So I'm going to shade that part just a little darker. And again, any point in that darkened region will work for both inequalities. Any point in this region will only work for the second inequality. Any point in this region will only work for the first inequality. And again, in that darkened region, it works for number 1 and number 2. And then in the blank region, it doesn't work for either inequality. All right, one more. Our first one here, our slope is 3, and our y-intercept is 1. So we'll start at 1 and go up 3 over 1. It's greater than or equal to, so we have a solid line. And since it's greater than, we will shade above. Our second one here, we need to get y by itself, so we'll add 3x. And we're left with y greater than or equal to 3x minus 4. So our slope is 3 over 1, and our y-intercept is 4. Oh, y-intercept is -4. So we'll start at -4, go up 3 over 1, go up 3 more over 1. It's greater than or equal to, so we have a solid line. And this one is also shading above. So you can see in between the two lines is where it's only red, but to the left of the bluish line, or above the bluish line, is where they intersect each other or overlap each other. All right, that's all, friends. Have a nice day.